Test.
Okay, good evening. My name is Carl Prather with Mirion Technologies. I'm our VP of Advanced Nuclear. I think this session ended up being about half the time that we expected, so we're going to cruise through some things pretty quickly. If you have any questions, come see us in booth G094. We'll be able to cover a lot more there with you, one-on-one. So today we'll be talking about accelerating new nuclear with our advanced solutions. I'm Carl Prather, and as we go through, I'll let Steve and Florian introduce themselves. Quick overview of the topics we're going to cover today. And then a short overview on Mirion and who we are. So Mirion proper has two divisions. We have a medical division and a Mirion Technologies division. Our Mirion Technologies division is sharply focused on supporting the nuclear energy sector. Mirion is a mission-driven organization. We see these words on the screen. These are not just words that get posted on a wall somewhere and forgotten. This is what Mirion is all about. This is that permeates our culture. It helps drive our decision-making processes, and ultimately to harness our unrivaled knowledge of ionizing radiation for the greater good of humanity is who we are. So you probably know Mirion as a supplier for health physics or rad protection equipment. We do far more than that. We're in life sciences, safety. For example, our detectors discovered the last 9 elements on the periodic table. We're in multiple space missions, so like with NASA, the ESA, we had equipment on the Artemis mission, an anthropomorphic model for testing shielded and unshielded bodies for cosmic ray effects for deep space missions. We discovered water on Mars. We have detectors in Italy right now looking for neutrinos in the search for dark matter. We've got a project in Africa, Risotope. So we're trying to, our technology is helping protect rhinoceroses from poaching in Africa. We are also deeply involved in the cancer treatment and next generation theranostics and also radioisotope production. So doing things to help move humanity forward. So you can kind of hear this and really Mirion's entire raison d'etre is ionizing radiation. One of the statistics I think on this slide that jumps out is that Mirion's equipment is installed in well more than 95% of the reactors on the planet. That makes Mirion one of the most prolific nuclear suppliers on the globe. There are probably 5 or less companies that can make that claim for being that pervasive, and kind of gives you an idea of how important and critical Mirion is to this industry's success. The roots of Mirion started in about 1950. I mean, it goes a long way back. We've got customer relationships that have been going on for decades. Right now, we're 2,800 people and about a $900 million a year revenue company. Some of you may have heard, though, we announced the acquisition of Paragon Energy Solutions, our intent to acquire them. That should be closed here in Q4 of this year. That will put Mirion at over 3,000 people and about almost $1.1 billion a year company. So we're here today to talk about some of the industry's challenges and what it'll take to be successful and get some of these reactors off of paper to actual operating reactors. So one of the areas of focus is getting the most commercial output from these reactors, maximizing reactor power output. So running at high temperatures, getting the most out of your fuel bundles. And Mirion has several different initiatives to help facilitate that for the advanced nuclear customers, including using some next generation sensors combined with AI and machine learning to help improve neutron flux mapping and fuel utilization. We are working to reduce rad protection operating expenses. So we're using more effective and robust equipment combined with some AI, again, machine learning on sensors to help facilitate preventative maintenance, predictive preventative maintenance. So you spend less time working on equipment. Decreasing security costs. And this equates to more or less exchanging people for technology. And this is a requirement for remote operation that is the kind of holy grail right now for the micro-modular reactor population. That's one of our areas of focus. We work with Sandia Labs and others to help realize that goal. Minimizing regulatory burden, we've got a company, Certrec, that helps facilitate both licensing and regulatory compliance. Outage downtime, unplanned maintenance, and optimizing your workforce. So the #1 constraint for the nuclear industry moving forward is expected to be lack of access to human capital and skilled labor. And ultimately, we need to close those gaps through technology, and Mirion recognizes that and is focusing strongly on supporting that. How are we doing it? Well, this is basically the solution cycle. So I mentioned earlier that you probably know Mirion as an HPRP company of providing dosimetry, contamination clearance, radiation portal monitoring. Well, we do far more than that. We support the entire life cycle of the fissionable material, from beginning to end, from mining to enrichment to fuel fabrication to actual utilization inside of a reactor, to waste management, and then long-term fuel storage. We talked briefly about the licensing and regulatory support that we have through our company Certrec, who's helping license some of these advanced nuclear developers' projects. HPRP, which you probably know pretty well, reactor monitoring and instrumentation, so that's our in-core, ex-core detectors, signal processing, and some of our electronic penetration assemblies, RMS, radiation monitoring systems. Mirion is the global leader. We have, I think, over 70% of the global nuclear power plants use 100% Mirion RMS. Radiochemistry, so high quality and precision equipment used in laboratories. Our secure integrated solutions, that's again our security group who's doing both physical security and also cybersecurity. It's been extremely important in supporting some of these advanced nuclear clients that Mirion's working with. Imaging, we have high rad tolerant cameras as well. And I think it's interesting, going back to the Paragon announcement, Mirion is clearly moving into a space where we are expanding our INC capabilities. So we're trying to provide more equipment, more solutions, but also, very important for reducing risk and speed to market, is providing a fully integrated solution for all of these various sensors. Bring it all together in one package. The final thing I'll say, and one of the things where Mirion has had the most success, is through our subject matter expertise. Historically, Mirion has sold things like just products, but our subject matter experts are really one of our big differentiators right now. We understand the science behind the applications, we understand the regulatory requirements, and what technologies out there, and have one of the deepest benches for access to that technology. We combine all those things and are helping our customers develop specifications that are both technically and commercially optimized. That optimization makes it much more viable for the reactor to make it off of a paper reactor into an operating reactor and deliver success that we all desperately want and need for our industry. With that, I'll turn it over to my colleague, Florian.
Yeah. Thank you very much, Carl, and good afternoon, everyone. I'm Florian Bourdet. I'm the Vice President of Radiation Monitoring System at Mirion. And for the 10 minutes to come, I will be pleased to introduce you with some of our solutions, as well as few projects we are currently very proud and that we are working on currently. So advanced nuclear solution, I think it makes sense to start with reactor instrumentation and control. So in this field, our value proposition is to perform reactor safety and to optimize the performance for the nuclear operator. So I can start with Neutron Flux Monitoring System. So in this field, what we offer is a digital platform that you see on this screen here. It's called ProTK. It's the only worldwide solution performing Neutron Flux Monitoring System on a digital manner. The main advantage of being digital is that you are very fast when you are doing the calibration. And since calibration happens every day or every 3 days, it is really a game changer. It's not only being fast, but also it's being more accurate when you do the calibration, which help to gain some potentially some few % of efficiency. So this platform is used for startup, intermediate, and power range, but also wide range of NFMS measurement. And it's, of course, combined with various types of sensors that we manufacture in-house. So it can be fission chambers, but also ionization chambers, and finally SPNDs, because we also perform in-core monitoring. Another field of application is what we call the radiation monitoring system. So in this field, we have various types of solutions, from process monitoring with, for example, a nitrogen-16 monitor to monitor the steam generator leakage, but also boron meter and effluent monitoring. It can be various types of effluent, and what you see on the screen here is a stack monitor, which is capable on one single skid to perform alpha, beta particles, iodine, and noble gases. As Carl mentioned, this type of system are currently in operation in more than 70% of the reactor worldwide, and we have a very strong experience in this field. What does it mean concretely for you as potentially a nuclear operator? The total cost of ownership is really reduced because, in fact, those types of systems required a huge effort of sustaining. And since we have a huge install base, you need to imagine that we have almost a bit more than 10 persons working on a daily basis just to perform the sustaining of such type of products. Two last topics I want to mention. First, electrical penetration assemblies. Those systems are very critical when you want to keep a proper third barrier of protection. We manufacture those systems in France, but also in North America. And the last topic, very important, and it is more and more the case with advanced nuclear players, it's the fuel burn-up measurement system and the fuel fail detection system. So here I would like to mention a strong partnership we have with X-Energy. So as you might be aware, X-Energy are working on a high-temperature gas-cooled reactor, correct? In this type of reactor, you have thousands of triso particles embedded in fuel pebble. A fuel pebble is what you see here. You need to imagine that you have thousands of people inside the reactor moving up to the down of the reactor. And what we offer to X-Energy is a fuel burn-up monitoring system that will automatically measure the fuel burn-up of the people in a very short period of time when the people goes out of the reactor in order to know if the people needs to be disposed or if it can go back for a new cycle of reaction into the reactor. So this is the type of system we offer currently to advanced nuclear vendors. Another very important topic is health physics and radio protection. So in this field, our value proposition is to protect your workers. So here again, we have a various type of solution coming from whole body contamination monitor that you see on the screen here, but also active dosimetry and telemetry and passive dosimetry. Of course, we also offer a portable instrument and environmental monitor. One important takeaway here is that, for example, the dosimeter, we are the world leader in this field with the best dosimetry solution, definitely. And we manufacture more than 35,000 units per year, which is quite impressive, I guess. So another point important when you are designing the reactor, we are having some designer in the room, it's very important to allocate the right space allocation from the beginning of the design, because most of the time for whole body contamination monitor, it comes pretty late into the procurement, but actually it takes some space. Huh? So this is just one takeaway for you. And the last type of solution I want to present you today is the fuel cycle application, and particularly the waste management. So in this field, we offer various types of solutions, from a low-level waste assay system. This is what you see on the screen here. So here you want to quickly assess your waste, and in like 1 minute or a little bit more, you want to know if you can go for a free release or if you need to process the waste. So this is the type of solution we propose. But also we have some tomographic gamma scanner which are capable to really focus on what is the characterization of the waste. And what you see here is a criticality alarm system. You will find this system in most of the fuel fabrication facility to monitor a potential criticality accident. Now, coming to a current project example, project we are currently working on at Mirion. So of course, today we are in Paris, so it's very natural to start with EPR reactor. We are very proud of our partnership with EDF. And part of our story is coming from the EDF partnership. So currently, all the solutions I have presented so far will be embedded into the EPR reactor, both in France for the EPR2, but also in UK for the HPC project, and we opt on Sizewell C project. Just be aware that we have also supplied all our solutions on Taishan and Olki Lyoto for this type of design. A next design which is becoming very hot this time is the AP1000. AP1000, you need to have in mind that currently in the world, in operation or in construction, there are 10 AP1000 design reactors. There are 2 reactors in operation in US and 8 reactors in China. Out of those 10 reactors, we are supplying the RMS system on 8 of those reactors. Particularly in China, we already completed 4 reactors at Sanmen and Hayang, and we are working on Shudapu and Shidao 1 units. VVER reactor, we are very proud to be a partner of Rosatom for the export market. So as an example, we are supplying a RMS system, more than 600 channels currently for VVER 1200 in China at Tianwan and Shudapu sites. Just important to note that we are also working on the PACH project in Hungary for PACH 5 and 6. And coming now, so we just saw large-scale reactor, and now we can speak quickly about advanced reactor. We are very proud of our partnership with TerraPower. As you know, TerraPower is a sodium-cooled reactor with some thermal storage in molten salt, and we are going to provide neutron instrumentation, radiation monitoring system, as well as spectroscopy. And it's a good example of project where we sat with the customer, with TerraPower, and we help them to define what is the right specification in order to perform just a design to cost and to not over-specify based on our knowledge. Last interesting project is Kijang. It's a very small reactor in South Korea. It's a 15 megawatt thermal that will produce radioisotope for medical. So it's a completely different scale as what we just seen. And we are proud to supply also all the radiation monitoring system, plus the neutron flux monitoring system I just presented before. So with all of this, I'm happy to hand over to Steve, who will present our last digital platform, Vital.
Thank you. So we talked a lot about instrumentation so far. I'm going to talk specifically about the Vital platform. So Mirion, it's a new innovation by Mirion that addresses the digital needs that go along with our instrumentation. So Vital is what we would call a digital platform where we're building in the background. There's, as important as those instruments are, we want to be able to monitor those instruments remotely, every instrument across the site. So we mentioned Mirion makes hundreds of different types of instruments in all areas of sites for both medical and power. And we want to be able to monitor those, sustain those systems well, maintain them. And So we knew we needed a digital system to do that. So when you're monitoring radiation around a plant, there's some challenges that you have, right? There's many different types of instrumentation that is used throughout the plant. Everything from health physics things to in-process monitors and environmental monitors around the plant. So there's a lot of different types of monitoring going on. We wanted one system to really do that, and that's what Vital is really meant to do. When you're monitoring all those instruments, it does produce a large amount of data. So we designed a new digital system that allows you to, it is expected to support tens of thousands of instruments, so at a site it can support up to. So we know there's a lot of data coming in. We store all that in what we call data historian, and that way you can use that data to optimize workflows throughout the site. Typically, you have different software solutions monitoring each type of instrument throughout the site. You know, RMS used to be traditionally different than health physics, but we knew there's big advantage to combining all that into one digital system that can monitor it all, because then you can mix data between the different types of systems. And when you have different digital systems, it's very hard to get things done across the site, to do reporting, regulatory reporting, or to analyze issues throughout the site. By combining this, we expect to offer a lot better solution to our customers for optimization at the site. And it also reduces the footprint, your software footprint at the site, so making it easier to manage all this data. So the Vital platform is really an ecosystem of products, but at its core, it is a data management system used to aggregate this data, report on it, and then once you have it in this centralized system, it gives you a single unified view of the data across your site. It's not, you don't have to go between different systems to really understand what's going on. It's one-stop shopping for that. And once you have this data in a single repository, it gives you advanced analytics. We can then operate more AI algorithms, machine learning, to actually utilize that data to optimize things at the plant. We tried to make it extremely easy to integrate into your system, to deploy it on a site, and to maintain it over time. An example is like the system, you can change the system, add to it, without affecting monitoring of all your instruments throughout the site. So it is a live system that you can modify as you go along. And really, ultimately, at the bottom there, we want to give you the data you need to optimize your workflows. You want tasks to be done very easily, reporting to be done very easily. That's what the system allows, or is designed for. This is kind of a high-level diagram of what it is. On the left, right, we talked about all the monitoring of your instruments on the left, but also there's laboratory equipment that we will pull into the database in addition. Vital it provides a bunch of services, so other systems like a plant computer could pull some of that data that it needs to do its own reports or calculations, as well as sometimes we use plant data for our calculations. If you want to do use flow rates or things like that, volume, you can pull that data back into Vital. The first application we built on the right side is supervision, because that's the piece that collects all the data. It's really the heart behind this, but it does allow us, having all that data, then does allow us to provide a lot more insight across the site, right? Dose management, asset management, which would be making sure your instruments are functional and maintaining them properly, but there's many advantages to this system once you have it at the site. So
digital transformation in energy production isn't just about keeping pace. It's about connecting the dots to stay ahead of the curve. With the Vital platform from Mirion, managing radiological instruments across your site is made simple. Vital Supervision, the first application on the Vital platform, replaces today's patchwork of information and interfaces with one application, connecting critical data for enhanced safety and efficiency. The Vital Supervision Notifications feature empowers your team to drive immediate action and informed decision-making through clear visualization of instrument alarms, alerts, or faults. An interactive plot provides complete device history for analysis, including alarms and measurement data. Vital Supervision integrates with your radiological devices and will support more devices in future updates. Importantly, the Vital platform also provides comprehensive audit logging, modern OS compatibility, and robust cybersecurity features. Powered by Mirion, Vital Supervision transforms supervisory workflows to meet today's radiological instrumentation needs and scale with ease.
Okay, that's all we have for our presentation. A genuine thank you to the audience for spending a few minutes with us. And if you want to learn more, get a little more depth, then we're at booth G094. Thank you very much.